Friends, once again, welcome. My name is Ashish Rakheja. I'm a trustee of Prem Jain Memorial Trust, and welcome to this third edition of the Net Zero Dialogue. As you are aware that we are running a 6-part series on living buildings, and this is the third edition of the same. The talk is becoming bigger. We have master speakers lined up for you. You've already heard from 2 speakers earlier who talked about the net zero approach towards building design. We have amongst us a very eminent speaker today. I will tell about him a little later, but first of all, about the program itself. Prem Jain Memorial Trust is a trust which has been established in the memory of Dr. Jain. Dr. Prem Jain, who was an engineer par excellence, had over 50 years of experience in consulting industry, building consulting industry. And thereafter, he became the chairman of Indian Green Building Council. Under his leadership, the IGBC grew from a small footprint to nearly 7 billion square feet, and making it the second largest green council in the world. Today, India proudly stands amongst the leaders of the green building movement in the world, because of the guidance provided by him. After his sad demise, the industry members came together to start this trust in his memory and carry the work forward. Dr. Jain's passion was students, and that's why the entire program which has been planned on the Living Building series revolves around students. Today we have colleges from across India. We have colleges from Bangalore, Mumbai, Cuttack, Bhubaneswar, Mysore, Mangalore. We also have a college from Chennai who joined since the last time, and a college from Delhi. So the footprint is growing. This talk goes out to over 300 people every time we've been doing. The numbers are growing. This time we have added a Facebook Live also to the talk. So while you are listening it online here on the Zoom platform, you always have an option to also go to the Facebook and see the telecast happening there live. We are talking about here in this Living Building series, a journey about being carbon neutral. And the human journey so far has encroached upon the environment, and the intent here is to take the low-hanging fruit, which is the building design, and move towards a carbon neutral economy. In the first session of this Living Building series, you had heard about the net zero energy building. The second one was a tour taken by Dr. Hariharan, where he took a tour of what he calls 6 strands of strategy, even before you take a brief from a client to create a building. These 2 talks have received wide accolades. The recordings from these are available on the PJMT, Prem Jain Memorial Trust website. You're welcome to go there and read about it and refer to it. Another aspect that I like to talk about is Greeno. Greeno is know everything about green. There's an option available to you online where if you go to the PJMT website, if you have any query which relates to green, feel free to ask there. Your queries will go to an expert, and those experts will respond to you. During this talk today, my request would be, if you have any questions, feel free to ask. Put the questions on the Q&A box there at the bottom. Don't use the chat box. It'll be very tough for me at the end of the day to moderate both the boxes. So I'll be only referring to the Q&A box, and in that Q&A box, whichever questions come, we'll pick them up. So the program will be that we have a talk by the eminent speaker, the master speaker, which will last for about 45 odd minutes. And then we will go on to the question answer session, which will do anything between 15 to 30 minutes, depending on the number of questions that are coming. I'd like to now hand over the mic to Dr. Hariharan, who is a pioneer of green building and environmental practice. He's an environmental economist, writer, and builder. He has founded and built businesses that mainstream technologies and solutions for zero energy development. So without much ado, let me hand over to Dr. Hariharan to take this forward from there, introduce the speaker and the topic. Over to you, Doctor.
Good morning again, Ashish, and thank you for those nice notes to start the session. Namaste to all of you present today. I welcome all the existing student groups from various colleges of engineering and architecture. Ashish spoke about all the cities. Bombay is also included this time. We have 2 colleges from Bombay who have moved in. Thank you so much for being here. A special word of greetings to the senior students of B Arts and the PG program at the Hindustan University in Chennai. You represent a large contingent this time with over 200 of you having logged in today, thanks to your Professor Ashok, who was himself a proud student of Dr. Prem Jain some years ago at the SPNA. I have some thoughts to share here. It has 3 parts, a backdrop to what Padhu is set to present today to you all. Some insights into Padhu, the extraordinary professional that he is, and a 3rd part on things we want from you as students. This is not to not acknowledge the working professionals who are here, but this is primarily for students, as we have been saying over these sessions. It'll take me about 10 minutes plus, but it'll be worth your while to listen to this story. A wonderful writer called David Mackay wrote a book called Sustainability Without the Hot Air about 10 years ago. He dedicated it to the first fossil-free generation of the world. Most of you in your late teens or early 20s are that generation who will soon transition to energy forms without use of oil or gas or coal or uranium within your lifetime. Your children will surely live on fossil-free energy. Let's clarify, if it's needed at all, that near zero energy is about near zero fossil energy. It's not as if we can't live without energy. You have to go back to the basic principles of Newton's laws, and you will know that energy is an absolute essential for you and me to even breathe. Like all the other species on Earth, can humans live off only the current sun and not the ancient sun and the fossils we inherited and lost in the last 150, 200 years? That is a question technology will answer in some years. This depends on how new technologies evolve, with hydrogen as the driving source probably, or other new forms of energy, who knows, and how that will transform. How much will we use of coal or oil or natural gas or solar and other renewables? Is the age of oil ended? Oil will be no more in demand once the world dumps IC engine cars. Your generation is smarter. You won't buy cars, you will rent them. And the rental cars will move to electric vehicles. Cities will get massive car parking spaces released for you to plan new and different things. In cities like Delhi or Bangalore, this is about 1/5 the city that could become parks or common public spaces. Energy scenarios will transform the very way you and I define life and lifestyle beyond what the COVID has shown us. New EVs are designed for 800,000 kilometers. Your regular car is never designed for more than 200, 250,000 kilometers. EVs are 10x cheaper today on fuel and O&M costs than an IC engine. An EV has 20 moving parts to about 2,000 plus parts of an IC engine. No surprise at all that EVs offer infinite mile warranty and near zero maintenance. It will soon be near zero energy from the fossil-based national grid too. The water scenario is all set to change dramatically. Using fresh water once and draining them will be history. We did this for the last 130 years or so, but we are moving into a new future there. We have a discussion on water coming up next week in this near zero dialogue. We will inform you of that. People like Padmanabhan have come a long way from the time when petrol was available at 1 rupee in 1972. He took up a career in energy research at a time when petrol prices jumped from 2 rupees to 8 rupees within 8 months, around late 1973. When what the world knows as the first oil shock or the OPEC crisis fell upon India, as it did upon many nations. That is a long story, but from about that time, some few remarkable people of rare dedication worked on energy efficiency, and how a unit saved is a lot better than an energy unit generated at a coal-based power plant or at a nuclear power plant or even at a hydro generating plant. How has India come from 1.7 GW or 1,700 megawatts to 370,000 megawatts today or 370 GW today? How has India moved from coal conversion efficiency of just about 40% to over 90% today? People like Padu were among the quiet leaders from the back end over the last 40, 45 years who made these things happen. Many of us know that the only solution for energy deficiency in India, as in the rest of the world, is energy efficiency. As Ratan Tata said this week, our cities today sport these ugly vertical slums that we call apartments. Our industrial clusters look like monsters that guzzle energy and water in the name of providing employment. Our builders and industry heads have shrugged their shoulders when it comes to owning up accountability for water and energy that these buildings and manufacturing units demand. We have gone on for 50 years without a care for what we do to wreak havoc. Architects and consultants grumble in private about how business heads who have to decide on project investments are only obsessed with costs, while businessmen challenge consulting professionals to offer solutions that balance cost and conservation. How can we change these things? Einstein once commented, "We can't solve our problems with the same thinking we used to create those problems." This presentation from Padu today will offer you a tour of what the next 2 decades hold for India, as all of you youngsters build and shape India's destiny. His thinking, as I know it is transformative. At the end of his conversation with you, if you are able to get some inspiration, some incentive to pursue such directions as he outlines, well, this Living Buildings series would have then accomplished something. Over the long years that I have been privileged to know him as a friend and as a co-trustee at the Alltech Foundation, Padu has always brought precision to his thoughts. He's like a surgeon, I was telling friends, with a scalpel when it comes to frontier concepts in energy. He's always precise. When Prime Minister Modi asked us all to switch lights off for 9 minutes, it seemed a simple enough act. Not so for Padu. The next day, he mailed me and another colleague on the quick math he did to arrive at how India's national grid had fallen sharply by 31,000 megawatts or 31 GW, when the fall expected initially was about 14 to 15 GW. Then he went on to explain in his mail the big difference that this made. Well, what's important is that his passion for new directions for energy efficiency is so complete that a simple lights off 9-minute campaign was an opportunity for him to secure a good understanding of the national load reduction potential of these important end-use energy efficiency or load management programs that India can and should take up into the future, with youngsters like you driving it, perhaps, as you make careers in such sectors. What is important for you to learn from a thinker like Padu is that he is always grounded, as you should be as architects and engineers, in the very basics of physics and of power and heat. The concepts are as old as when James Joule set them down in 1815, 1820. I recommend you to read Bill Bryson and his short history of nearly everything if you want to know more about such fascinating people who broke the frontiers of knowledge for us over the last 200 years, particularly in the last century, in the 20th century. The principles have remained the same, but how you use these to invent directions is the difference that Padu will make for you. He explained recently, for example, as to why a unit of power you consume at home or at any place means generating 4 units at its source. This means if your house consumes about 400 units a month, as most of our middle class homes do, you're actually making the country produce 1,600 units because of this 4X syndrome. Imagine a mall or a factory making cement or steel and all the energy they devour. That, in essence, is why energy efficiency is way more important than generating or supplying power. By the time Padu has finished making his presentation, you'll see why demand-side thinking for all of you young professionals is a lot more important than supply side. When I invited him to present to you on this, the third of the 6-part near zero dialogue, his first recall was of a framework he had used for his students at Johns Hopkins in Baltimore, an hour from Washington, DC. That was about 5 or 6 years ago, I think. He says that program was a hit with those students. He's happily sharing with you all today that same framework he presented then. The only difference is that he taught the class for 3 hours over 2 separate sessions. Here he's condensing it to 45 or 50 minutes. Padu, you can take a little more time if you want to, because there's a great deal of anticipation. People are looking forward to listening to you today. Well, for a quick profile of Padu, hard to capture in brief, the extraordinary work he's done over nearly 50 years of his work, 47 years, I would think. He has been the father of many innovative energy initiatives in India, in Afghanistan, Sri Lanka, Bangladesh, and other South Asian countries. His distinguished career years saw him share time between Washington, DC, and Delhi, while in recent years, he has been a global energy consultant at large. He has shared time between Bangalore and Pittsburgh for now, until the COVID crisis sort of grounded him in Bangalore. More recently, he worked on the unifying of the power grid for Saudi Arabia and the UAE. His passion for developing the emerging scenario on the water energy nexus is singular. At the Altec Foundation, we are hoping to break some very good ground in that area of the water energy nexus. Green buildings is a subset of the work he does in these spheres of energy. We requested him, therefore, to focus on buildings, not as much on agriculture and industry, which are also his areas of focus and specialization. In fact, were it not for his quick intervention 20 years ago in 2000, the IGBC, which is today a front runner for the green building movement, would not have happened as quickly as it did in less than 12 weeks before President Clinton visited India. But that's another story. We'll have to keep it for another day. IGBC is in that sense an Indo-US bilateral initiative. The first private sector plant in India was to his credit in many ways. He initiated the first cogen plant where a sugar plant produced and consumed power out of heat waste. He brought major innovations in the power sector for reforms both sides, the grid, generation, and distribution, and he continues to work in those areas. So many grand national narratives that began with him. The Green Business Center in Hyderabad, the Indian Green Building Council, which all of you know about, the CEPT University's R&D Center, the Energy Conservation and Building Code of India, the Water Energy Nexus program for agriculture that he did in Bangalore first and left it to the power sector to see if they want to take it up further. The Bureau of Energy Efficiency, the Center for Lighting Efficiency in Sri Lanka. He designed the very first World Bank line of credit for energy efficiency in India that led to demand-side management strategies in the power sector across 4 states and, well, Mumbai too. His is a story spanning, as I said, a half-century of singular devotion to moving the energy agenda to the demand side to create a whole new landscape of institutions. He's continuing at the Altec Foundation to work on more fantastic initiatives. One is an EPIC program on water energy nexus for Bangalore's urban, industrial, and agriculture sectors. Another is a program to bring energy efficiency in industrial MSME clusters. A third is a phenomenal program for laying down a doctrine of energy efficiency for cities like Delhi and Bangalore. Now you see why I had to take as long to set the context. Here's a career beckoning many of you youngsters, I must tell you. If you're inspired by what he has to say, if there is a single message for you all that he is offering, as David Attenborough said this week on BBC, stop wasting. Stop wasting of any kind. It could be power, as Padu is going to tell you about. It could be water, as someone else is going to speak about the next week, or food. And we'll get somebody to speak about that too to you someday. Stop wasting anything at all. We are over 500 people today. I never cease to be amazed at what technology has done to our lives. Like many of you, I'm beginning to see that even post-lockdown, we will have moved to these very energy efficient ways of reaching out. As Padu said this morning, it's pretty unsettling to be sitting in the quiet of your study or your room and have 500 plus people connect with you the way we are doing, you and I. Thanks to all of you who have raised questions over the last couple of weeks. We have featured all of them with your names credited to questions that you asked. A request to you all on questions you raise or comments you send, especially to those who are senior professionals who are listening in today. Please use the Q&A window. It's easier for us to monitor, as Ashish said. And you as students, I request you to post only questions for which you need answers that you can't find yourself on the web. The sharper your questions, the better the learning for all others in the group too. All senior professionals who have joined us today, please raise questions that will help these students learn better. You're here to see if you can mentor this process for us too. If you have insights to share, please offer them. This is not about questions alone. Many of you are thinking young professionals. Your views are important, so don't stop with questions. Please give us your insights and perspectives too. The NITE faculty, thank you for raising many questions in previous sessions. We haven't answered all of them. These are questions of a universal nature, especially those from the NITE school faculty. They don't need to be answered. And I'm saying this to all of you as students, as much as reflected upon by all of us together. Not all questions always have answers. I hope all of you students have read carefully the detailed reference reading we have offered through your faculty heads for this session on promise of energy efficiency in India. I'm sure you will have all studied well the Q&A sections. Thank you for those who have already responded. Architect Sakshi in the team backend has been monitoring these. They will provide invaluable learning for you, let me assure you. They will lay the practical foundations you need when you get down to picking up a job. On another matter that I need to ask of you all, feedback form was shared with faculty heads of all colleges. I request both faculty and students to respond to the 5 simple questions we have asked your inputs for. I agree with you all. Some of you have sent some of these inputs, which are very, very wonderful. You want us to see if we can focus on more case studies. You want us to see if we can focus on specific challenges presented with the story of how a master speaker thought through the process and created the solution. We will work on that. You can be sure of that. We will be also requesting all faculty of all colleges to send back the feedback form if you haven't already done so. If you haven't got it, please get hold of Sakshi. She'll send it right away to you all. Be assured, we will study your responses and internalize. Send in your questions on the Q&A window, as I said again. Ashish will anchor the session today and will raise questions for Padu at the end of the presentation. Recording of this, as well as the reference reading, will be hosted by tomorrow, while detailed responses will be posted on the Q&A section of the website by Monday. It's time for me now to hand the mic over to Padu. Remember, you are embarking on a journey over the next 20 years of your career life that will open an era beyond the age of coal and the age of oil. Padu's thoughts are anchored around those significant contexts of the far future. Over to you, Padu, unless Ashish wants to check in with a word or two.
Oh, we are good. I think looking forward to listening to Padu. Over to you.
Padu, it's your time. You could put on your deck.
Can I request the organizer to stop sharing the screen, please, so that Padu can put it up?
There we are.
We can see the screen now, Padu, and yeah, good to go.
Good morning. Good morning to you all. I would like to begin by paying my homage to an extraordinary man, Dr. Prem Jain. He represented, in a sense, the concept and ethos of sustainability in all the work that he undertook. Just 2 examples. His professional leadership at ASHRAE as a HVAC expert. He was known as the father of air conditioning in India. And more recently, before his demise, as Ashish mentioned, he was the chairman of the Indian Green Building Council and took it to great heights. And central to whatever he pursued in his career, in his fantastic career of 50 years, was the education of the youth. So it's appropriate, eminently appropriate, I should say, that this Prem Jain Memorial webinar reaches out to students in many universities and colleges in India and the world. Thank you both, Ashish and Hari, for your kind words of welcome and introduction. Hari has indeed set the tone of my talk on the promise of energy efficiency in India. Net zero or nearly net zero buildings are highly efficient buildings and extremely very low on energy demand. They produce as much energy as they consume when accounted for, say, on an annual basis. So a key foundation of net zero energy buildings is the application of energy efficiency in virtually every facet of the building design. Hence, it's important for both practitioners, such as architects and engineers, and students, to understand and appreciate the concept and applications of energy efficiency in a country's economy, and specifically in key sectors like buildings and industry. I would, in the next 40 or 45 minutes, cover the following session objectives. Hopefully, the student should, at the end of my talk, understand the strategic role of energy efficiency globally and in India, appreciate the impact of energy efficiency on sustainability. I'll make a very brief introduction to what I refer to as tectonic green shifts in sustainability, of which energy efficiency is a major performer. Hopefully, by the end of the talk, you will be aware of some of the trends and barriers to energy efficiency in India. And importantly, you'll be introduced to the potential and opportunities for energy efficiency in Indian buildings, and to some extent in the Indian industrial sector. Well, this is a graph from the IEA. The IEA stands for the International Energy Agency, and they're headquartered in Paris. And they have as their members the developed countries, the OECD countries. Sometime in 2008 or so, IEA had simulated and modeled the impact of energy efficiency on global carbon emission reduction between 2008 to 2035. And the purpose was to find out what is it needs to be done globally to maintain carbon emissions on or around 450 ppm in order to limit global temperature rise to within 2 degrees centigrade. And this was the graph in case the world were not to do anything. And this was the graph if the world were to incorporate a lot of measures. So the IEA study essentially came out with a fact that by 2020, that by this year, efficiency could take us down the path of a 450 ppm scenario. And efficiency would amount to almost 71% of the emission reduction, of which there would be end-use efficiency through technology and practices amounting to 34%, and end-use indirectly through embodied energy and so forth by 33%. And the balance would be through renewables, biofuels, nuclear, carbon capture and storage. Around the time in 2011, the IEA did a very interesting study. They looked at the impact that energy efficiency had in 11 of their 17 member countries. And they found that in each of these countries, whether it is the US or Canada or Japan or many countries in the European Union, that more energy was saved due to energy efficiency than was generated through coal, oil, nuclear, hydro, or whatever. In other words, energy efficiency was not an embellishment. It was not an icing on the cake. It was not something to do good. As Americans say, it was not just motherhood and apple pie. But energy efficiency was the first fuel, more important than any other fuel. I think we need to keep that in mind as we proceed. Coming to India, the sectoral energy consumption in million tons oil equivalent is largely industry and buildings and transport. Industry which involves direct use of energy and non-direct use of energy, because you do use energy as feedstock in some of the industries, such as fertilizers and refineries and petrochemicals. So the total amount of energy used in industry in India, approximately around 40% of the total consumption. Buildings is about, in every sense of the term, buildings, office buildings, residential buildings, and so on, and all of it would be around 30%. Just want you to keep in mind these numbers, because most of my presentation following this would be either on buildings and to some extent in industry. One way of determining how efficient an economy is by calculating its energy intensity, or the amount of energy consumed divided by the country's gross national product. So we have this graph of China, the G20 countries, India, and the Kingdom of Saudi Arabia. And you would find that between the year 2002 onwards until recently, China's energy intensity, particularly after 2006, has rapidly reduced. In other words, Chinese industry and Chinese economy have become more and more efficient. In fact, the reduction has been 5% year upon year, the largest reduction by any major economy in the world. India too has reduced its energy intensity. Not as much as China. We have reduced it at approximately 1.8% year upon year. We continue reducing it, although we are beginning to plateau a little bit. And G20 too has reduced its energy intensity. In other words, most countries in the world have, over a period of time, reduced the energy intensity, which is the energy consumption per unit GNP. But some countries, such as the Kingdom of Saudi Arabia, among the GCC countries, which is the Gulf Cooperative Council countries, actually increased its energy intensity for much of the century, much of 2000 to 2010, and now it has plateaued off, largely because energy is cheap there and inefficiency rules in many of the end uses. But the fact of the matter is, energy intensity is reducing due to modernization and so on and so forth, but the pace and direction of energy intensity reduction needs to be accelerated. Now, how do we accelerate the pace of energy intensity reduction? I call it green tectonic shifts. There are 6 shifts that we would have to do in India. And I can't talk about all 6 of them because that will take a long time. So I'll just focus on the ones which are starred. The shift to demand side of the energy equation, and I'll talk about it a little later. Harnessing renewables. The government of India is very aware of the role of renewables. Today we have a target of meeting renewable capacity of 175 gigawatts by 2022 and 425 gigawatts by 2024, largely through large-scale grid interactive renewable power systems, as well as decentralized systems on the customer side of the meter. There's this transition to smart grids, which is getting to be extremely important, which is automation and digitalization of the electricity grid, or smart grid as it's called, which can bring us a lot of energy savings. Then there's the movement to clean coal. Remember that almost 60% of our total power generation is thermal, of which much of it is coal. And unfortunately, India has poor quality coal, high in ash content. And that impacts the reliability and availability of our power plants. So it's very important to use clean coal technologies. which would provide for higher efficiencies. And then we have advancement of green building, which I'll be talking about in some detail, and then the energy water nexus. Shift to demand side of the energy equation is my first tectonic shift, number one. This is more in planning, more in the mindset. We have done well on the supply side. If you look at the energy equation, supply on one side and demand on the other, the country as a whole has done well on the supply side. As Hari very rightly mentioned, in 1950, we were about 1,700 megawatts or 1.7 gigawatts. Today, we are about 375 gigawatts. So by any reckoning, we have done well on the power generation side. We have done well on the coal production side. In the 50s, we were producing about 40 or 50 million tons of coal per year. Today, we produce about 800 million tons per year. So we've done very well on the coal side. So without a doubt that on the supply side, we have done well. But we must recognize that supply side is centralized decision making. It doesn't take too many entities to take a decision on putting up a power plant. It requires agencies at the center, such as the Central Electricity Authority, the Ministry of Power, the Planning Commission, the Ministry of Finance, and at the State Electricity Board, and a few others, and the Environmental Ministry, to take a decision on putting up a power plant. Of course, power plants are costly. They don't come cheap. Today, it's about 8 to 10 crores per megawatt for a thermal power plant, maybe 15 to 16 crores per megawatt for a hydro power plant, and probably higher for a nuclear power plant. They are not exactly human resource intensive. In fact, they're less human resource intensive, but they have an enormous and adverse environmental impact. On the other hand, on the demand side, it's very decentralized. It involves a lot of people. Every person, every citizen who consumes energy in one form or the other would have to play a role, whether it's the industrialist, whether it's the building owner, whether it's the taxi driver, whether it's the housewife at home. So clearly, it involves decentralized decision making. Lower capital investment, and I'll get into that a little bit because one needs to compare capital invested on the supply side to capital invested on the demand side on an even playing field. They are highly HR intensive. A lot many more people are required. And they have very little or no environmental impact because they're clean energy based. So I have a pop quiz at this point, which is a greater challenge. Generation of 1,000 megawatts of power or saving 1,000 megawatts of power. Interesting point, because as you try to come out with an answer to that, you'll have to justify it based on certain criteria. Now, what is that criteria? Now, if you look at investment, India needs to balance investment in supply and demand. That's very clear. So on the left-hand side, you have supply-side investments to put up power plants, put up transmission facilities, put up distribution facilities, and so on and so forth. On the right-hand side, you have investments in end-use efficiency. In this case, end-use efficiency in the building sector. And there are many, many of them. We'll talk about each one of them separately. But for the moment, just look at them as one block. You have LEDs and T8 lamps, you have efficient air conditioning systems, window glazing, insulation, and so on and so forth. Clearly, the balance should be on the demand side. Thus far, for very many years, it had been on the supply side. But now we need to move more and more on the demand side. And we'll talk about how exactly this can be done. An important point is that, and I alluded to it earlier, I'd just like to make the point, that global studies, and even studies in India, for very many years, has shown that energy efficiency is much more cost effective than energy supply. In fact, it costs anything between 1/5 to 1/2 to save a megawatt of energy or power as compared to an equivalent generation to fossil fuels, be it nuclear or renewable energy. When I said it costs 8 crores per megawatt of installed capacity for a thermal power plant to generate 1 megawatt of power, it probably costs 1/5, that is 1.2 or 1.3 crores for saving an equivalent megawatt through energy conservation measures of the kind that I illustrated earlier. But the balance, however, as I've said, and I'm repeating myself, continues to be on the supply side. And now one needs to think of ways and means to tilt the balance towards energy efficiency. So summing up briefly what I've said thus far, energy efficiency is the bridge between a world dominated by oil, coal, to one of the future, which will be dominated by renewable energy, gas, and so on. But it's a very vital bridge. Now let's sum up the energy efficiency trends in India. It's clear from what I've said earlier that energy efficiency is a strategic solution to address national energy security. We are importing almost 85% of our oil. We are, in a sense, hooked on to oil from the Middle East to an extent that is, which could threaten our national security in case of volatility in oil prices. Today, the oil prices are down, tomorrow it will go up. We have made a very halting progress towards adopting energy efficiency as a resource. It is still considered to a has-been and also ran, an embellishment, an icing on the cake, motherhood and apple pie, all kinds of statements. But as I mentioned earlier, energy efficiency should not be seen any different from oil, coal, electricity. And in fact, all energy plans should look at efficiency as an energy resource. Clearly, in India, energy efficiency is the first field. Several studies have been done in OECD countries, but if a similar study is done in India, and I've done some studies in some pockets of India, where energy efficiency has saved more energy than what has been obtained from renewable energy, for instance. Efficient public use of energy represents a major opportunity. When I talk about public use of energy, I mean energy use in sectors such as agriculture, in municipalities, in government buildings, etc., where there is significant amount of opportunities to save. But we have made some savings. Don't get me wrong. It's not as though that we haven't made any progress. The greatest advances in energy efficiency in this country have come from vendors. Today, there are many manufacturers of electric motors and furnaces and boilers who are much more efficient than what they were during the time when I started my career in 73, 74 in energy efficiency. Far more efficient. Some of them are as good as world standards. Many others are still behind world standards. Then we have corporate leaders, large industry, such as pulp and paper, refineries, cement, petrochemicals, steel, and so on and so forth. These large industries actually, in a sense, have done very well. Of course, not all of them, but a great many of them now today have introduced energy efficiency as part of corporate strategy. In many of these industries, you have energy management cells, you have energy auditors who audit the energy use, and many of these industries are modernized to reflect lowest energy consumption. Their productivity of energy use is reasonably high, and in some cases, they are among the best in the world. The cement industry is a case in point, where Indian cement industry uses the least amount of energy to produce a ton of clinker, both thermal as well as electrical energy. And they've done it over a period of time through technological modification, better practices, and so on and so forth. The steel industry has also done well, not as well as probably some of the steel industries in Japan and elsewhere, but nonetheless, they are better than the global average and among the leaders in the developing world. So we have among the large-scale industry a lot of lessons that we can be proud about. Then you have energy service companies. These are small service organizations, consultancy organizations, which actually invest in energy efficiency in a particular unit or in a building and share the energy saving with the owners of the building or the industry. These are small entities, and we have not done very well in encouraging the energy service companies in the country. China, by way of contrast, where I said the energy intensity has reduced year upon year by 5% since 2004 and 5 to today, has done extraordinarily well in mobilizing energy service companies to deliver energy efficiency services. So this is a lesson that we can learn. But frankly, the best lesson or the best result is obtained when public policy mechanisms are teamed with business policy. I think this is important, and I'll just show you one more slide about exactly what I mean. The key elements of India's energy efficiency strategy, and to keep it simple, I divided it into two. One is public policy-based mechanisms. These are mechanisms which come out of the Bureau of Energy Efficiency in the Government of India, which is the nodal agency to promote energy efficiency in the country. And then you have, on the other hand, business-based energy efficiency mechanisms, which are driven by enterprises. So among public policy mechanisms are equipment labeling and minimum efficiency performance standards. Today, several equipment such as air conditioners, refrigerators, some motors, etc., have to be labeled. They have a minimum efficiency standard. You have the Energy Conservation Building Code, which was promulgated in 2007 by the Ministry of Power, Bureau of Energy Efficiency. And today, ECBC is mandatory for government buildings. Many buildings are compliant. Still, there are many more buildings yet to be compliant. You have lighting energy efficiency market transformation, and a remarkable transformation has taken place largely due to the efforts of EESL, Energy Efficiency Service Limited, a public sector undertaking under the Ministry of Power, which has, over a period of 5 to 6 years, transformed lighting in the country by aggregating the market. They have been able to reduce the cost of LED bulbs in municipalities, in homes, and so on. And today, to a large extent, India is definitely a leader in lighting efficiency. There are a number of demonstration projects in the country. Testing and certification is again a responsibility of the state. And then the state also provides a lot of financing incentives, such as accelerated depreciation, investment tax credits, and so on. Matching this and working in consort with this has to be business-based mechanisms, such as energy audits, building energy audits, and industrial energy audits. And we have certified energy auditors in the country. We have green rating programs, such as the one run by IGBC rating program, and the GRIHA program, and several other programs in the country. We have energy efficiency demonstration projects. We have access to financing. ESCOs, as I said, we haven't done as well as we ought to, but it's beginning to happen. And then there is a fair amount of project aggregation taking place. Now, I could not cover all the tectonic shifts. I just, as I said earlier, just touched upon renewables and touched upon smart grids. But an important tectonic shift, and a tectonic shift, if I haven't already said, is large. It should be awesome. It should be at a national scale to promote efficiency to the demand side, and also to achieve some of the benefits to improve energy performance. So the tectonic shift number 5 is the energy water nexus. See, India's, and I think it's important because one needs to understand that you have energy for water and water for energy. You need energy, and what I mean is you need energy for pumping water, for conveying water, for treating water, and you need water for generation of power in thermal power plants or whether hydropower plants. For instance, 80% of our total fresh water in the country is used in agriculture. So that's a good example, of which 50% is groundwater that uses anywhere between 25 to 35% of the electricity in some of our large agricultural states, such as Punjab, Haryana, Rajasthan, Gujarat, Tamil Nadu, Karnataka, Maharashtra, Andhra Pradesh. These use a fair amount of the total electricity for agricultural pumping. And in many cases, especially in home, water is not metered. It's generally a fixed rate for domestic consumers. The marginal cost is zero. Whether you use 1 liter of water or 100 liters of water, the marginal cost is zero. So the energy water nexus, understanding it, will help us address conservation issues that arise from water and energy's interdependence, the interdependence I just talked about. This is a explanation of the water, energy, and food mixes. As I said, you need energy to treat and move water. You need energy to extract and produce energy. Rather, you need water to extract and produce energy. And then you need water for home consumption, for irrigation, and so on and so forth. And coming out of the energy and water interaction is food. And food definitely is an important element here. Now, when you look at this, what could you do to reduce the inefficiencies in the energy cycle and in the water cycle so that you get the maximum crop for every drop of water and you use the water efficiently? Now, this is the map of land cover, and it contains a lot of data. It's too complex to read on a screen, and I won't ask you to do that. But if you take a few seconds and look at it as a picture rather than as a data set, at even a quick glance, it is not unreasonable for you to ask what the color orange represents. Orange is for cropland, and red represents urban and built-up areas. An important theme emerges from this. It is the theme of the importance, indeed, from a strategic and policy perspective, of the need for water to irrigate this vast canvas of continuous cropland. Well, as many of you know, India's groundwater levels have been dropping approximately 1 feet per year. That's a lot. More than 110 cubic kilometers of groundwater virtually disappeared in the first 10 years of the year 2000 to 2010. That is double the capacity of India's largest water reservoir, surface water reservoir. That is the upper Wainganga in Madhya Pradesh. And is triple that of Lake Mead, the largest man-made reservoir in the US. Satellite pictures show that groundwater is being depleted at a mean rate in excess of the rate of replenishment in the Indian states of Punjab, Haryana, Delhi, Bangalore, and so on and so forth. I know, as Hari said, there's going to be another session on water, and I'm sure the master speaker at that time will cover all of this in great detail. I introduced the two previous slides on agriculture to basically illustrate the potential and application and opportunity for a strategic co-management of energy and water. Now, this is a point which Hari referred to when he talked about delivery of a unit of electricity to a building or to a house owner. What does it entail in terms of energy on the input side? This is the principal technical losses in the urban sector. Now, if you look at this carefully, what it basically says, for an output of 1 kilowatt hour, you would need an input of 24.7 kilowatt hours thermal. I think that's important to understand, that you have what is known as the second law of thermodynamics. You can't convert all heat into power. There will be some irreversible losses, unavoidable losses, but the maximum efficiency of conversion, it would be around 40 to 45%, maybe 42%. So there is going to be a loss. In this case, on the average in India, thermal generation operates at 30% cycle efficiency. So you have a 70% loss right here, and there's nothing much you can do about it, because that's the Carnot principle, Carnot efficiency rather. And you could up it up. You could reduce from 70% to maybe 65% is more for technology, more than anything else. Then you have a 10% loss in the power plant in the turbo alternators, which is little on the higher side. It could be even 6% or 8%. Then you have transmission losses because the power from the bus bars goes from the power plant, goes into the transmission grid, and there is some loss there. And then you come down to distribution where the losses are quite significant. And we have something like 30–35%, although I must say that India has done quite a bit in reducing its losses, but still there are areas and places where energy losses could be as much as 35%. These are both technical losses as well as commercial losses. Commercial loss is a euphemism for theft and dacoity, as they say. But 35% is probably a little on the higher side, but nonetheless, it's an important loss. And then you come down to the end user. From 24.7 kilowatt hours, you work your way right through the cycle. You come down to 4 kilowatt hours to the end user. And the end user efficiencies are just about 25–30%, whether it's motor efficiency, lighting efficiency, or what have you. So there's a significant loss down here, and you get 1 kilowatt hour. So can you imagine, for 1 kilowatt hour of output electricity, you are having an input thermal of 24.7 kilowatt hour. So this, what can you do to improve it? Well, you could bring it down to 6.6 kilowatt hours input thermal to get an output of 1 kilowatt hours by interventions. You know, as I said, thermal generation, you could reduce the efficiency loss from 70 to 62%. You can't do much more than that. 62% loss means cycle efficiency of 38, and that's very high for a simple Rankine cycle system. You could bring down turbo alternator loss to 8%, probably even lower. The Japanese do it at 2 to 3%. You could bring down transmission losses to 6%. It's high, but you can bring it lower, but let's keep it 6% for the moment. Distribution loss from 35%, one can bring it down to 10%. That will be very good. Many of our distribution companies have brought down their distribution losses to 20, 18, 16%. There have been certain sections in the country which have reduced the distribution losses to 10 to 12%. So it is possible. And then end user loss, you could cut it down from 25% down to about 50% loss. You cannot convert all the electricity into output on a 100% basis. But clearly there will be some loss, but 50% loss is perfectly acceptable. You could come down to an output of 1 kilowatt. The purpose of this slide, and it's theoretical, it's hypothetical, but it's just to give you an understanding of a power system where one can make interventions, technological interventions, as well as other interventions to bring down the losses. Now let's come to why buildings. I had alluded to this earlier. Buildings consume 29% of our electricity consumption in the country. Industry consumes approximately 46%. So between buildings and industry, the two largest users. Balance is agriculture, and then there are others, municipalities, and so on and so forth, public water works, and so on. So let's just focus on buildings and industry. So I'll give a couple of case examples of energy efficiency in buildings, mainly to tweak your interest and to give you some ideas of some of the fundamental principles. It's by no means an elaborate coverage. The experts really in this area are Ashish and Hari, and they could tell you a lot more than I could. But let me tell you a little bit about certain opportunities through some case examples in buildings and in buildings. One is reduce loads. That appears, straightforward and simple. Just reduce the energy load. And you could do it through building envelope design. Building envelope means walls, roofs, floors, windows, doors. They have a huge impact on the cooling or heating energy used to condition the air inside the building. Building envelope improvements include insulation, energy efficient windows. You can have airtight windows. You can have windows with high R values, low emissivity windows, and so on and so forth. But there is a great opportunity to reduce consumption of energy, cooling or heating or even lighting by making changes in the building envelope. Glazing is another area. There are selective glasses or spectral glasses as they're called, or low heat gain glasses. They allow natural light to come in but reduce solar heat coming in. Then you have chromogenic glasses, like your cooling glasses, changes color automatically like sunglasses, allows more or less heat or light depending upon temperature and natural luminosity. So there could be a lot could be done through glazing. And then shades, window shades, they block sun rays from entering. Indoor curtains do that as well. Then you have passive strategies. And here, the important one is natural ventilation. That's the natural movement of air that sweeps a room or a building through careful design and location of low and high pressure natural draft systems. Through careful design of door location and window location, one can move the or alter the movement of air across a room, through a room, bring about a certain amount of cooling effect in the process, reduce air conditioning loads. In fact, in many cases, you don't need any air conditioning at all. It can substitute entirely for air conditioning. So natural ventilation is important. Then lighting. Lighting is a major consumer of energy, as I said. LEDs consume 1/10 that of an incandescent lamp. One can replace a 40-watt incandescent lamp by a 6 or 8-watt LED lamp. They last longer, they run cooler. Daylighting is even better. You could allow natural light to come in, for which you don't need to have any artificial lighting. There are various ways and methods to do that. And it's an important step for energy efficiency in a building. And then you have thermal mass. That is the heat absorbed by a brick. It's a function of its weight and specific heat and the brick temperature. A high thermal mass brick means, say in a cold climate, would absorb a lot of heat, which at night it dissipates and into the atmosphere and wastes it away. So having bricks with low thermal mass contribute to efficiency. And then you have active strategies. I spent part of my winters sometimes in the US, where we have underflow heating. We can use either low impedance electrical tapes to heat the floor, but also by circulating warm water through a series of cross-linked polyethylene piping loops under the floor. The warm flow radiates heat to objects and occupants in the space. It's also called radiant heating. Then you have radiant conditioning or radiant cooling in hot seasons. It's not the traditional HVAC forced air system, which is not energy efficient. It uses the same principle as underflow piping, explained as earlier. Same underflow pipes are used. In radiant cooling, the cool floor surface pulls heat from objects and people in the space. In many cases, it can replace or supplement the HVAC system at a much lower energy cost. Then you have district strategies, and these are combined heat and power systems, much more efficient. They're also known as cogeneration systems, where you meet heat and power requirements for a cluster of buildings, a cluster of commercial buildings, and thereby improve the efficiency of energy conversion. And then there's the recovery of energy. This is really recycling and reuse of energy. Let me provide a small example. See, after cooling a room, the indoor air is forced out and replaced by outdoor hot air before it is cooled as it enters the room. So you have indoor air which has done its work, given up its cold, but it's still cold enough, and then it is removed from the room through a duct, and you have outdoor air which is hot, let us say at 40 degrees, and you've got to cool that down to let's say 22 degrees. But if this indoor air, which is being forced out through the duct, is allowed to exchange its coldness with the outdoor air at 40 degrees and bring it down to let's say 32 degrees through heat exchanger. And these are known as Munter's wheel or energy wheel, which transfer heat or cold from one stream to another and bring it down, let's say, from 40 degrees to 32 degrees. Then the amount of energy that you require to further cool the 32-degree stream of air down to the room temperature that you want, that is 22 degrees, can be substantially reduced. You can reduce 15 to 20% of the energy required in an HVAC system if one were to use pre-cooled air as the air for which you need further cooling. So that's one example. Then you have domestic water and grey water use. And again, I'm sure this will be discussed by the next master speaker on water. But the grey water use is the need of the hour. Amazing amount of savings. Hari made a reference to it, where he said that one cannot use fresh water as the way we have been using it. One has to reduce its consumption, recycle it and reuse it. And that should be the mantra for both energy and water. Then you have solar generation. I won't spend too much of time on this. Rather, self-generation. These are solar rooftop systems. They do play a very important role in the building energy, especially net zero buildings. You have wind and waste to methane and so on. And then you have offsetting, and this is useful for meeting carbon targets. For instance, a developed country could invest in energy efficiency in a developing country, and the carbon saved could be credited towards meeting its own target which it has to comply with. So it's kind of offsetting, and one can do it between two different sectors in an economy, between one industry and another, and so on and so forth, where one could offset the carbon that one would otherwise have consumed and credit it to somebody else through a kind of a transaction cost. Now let me move from buildings, and the idea of on the building was not to be exhaustive, but just to kind of tickle your imagination so as to understand the opportunities and possibilities here. And I'm sure there will be other sessions which will take the building sector to the next level in terms of this explanation. If you recall, in one of my earlier slides, I had mentioned that large industry in India have done reasonably well. I don't want you to get the impression that all large industries are very, very efficient. No, that's not the case. We have a big bandwidth. You have very efficient cement industries, and you also have some inefficient cement industries in the cement subsector, and so on and so forth. But by and large industries know what to do. They are well networked, and today one can get a lot of information through professional meetings and so on and so forth. The opportunities really lie in India in the MSME sector, which is the medium, small, and micro enterprises. They constitute approximately 90% of the total industrial units in the country. They contribute to 45% of the industrial value addition. They comprise 40% of the total exports. They employ a lot of people, 40%. After agriculture, the second largest employer, contribute to about 8% of the country's GDP. We have 51 million working enterprises across 60 odd clusters. They're normally in clusters. So you have ceramic cluster, you have light engineering work cluster, you have re-rolling mill cluster in various parts of the country. And they're dispersed on the country and produce a range of diverse products. I think it's important that one recognizes that energy is probably the largest single cost center for a small scale industry. In forging and foundries, 50% and even more cost is due to energy. And then in other industries too, whether it is sheet metal work, molding, ceramics, it's 15, 20, 30%. So it's a significant portion of the total manufacturing cost. And reliable energy is also very important. A small scale industry would also not have to be efficient. It will have to be efficient in order to be productive, in order to be cost effective. But it will also have to receive a reliable source of energy. Because if you imagine that you are a foundry and you have a large furnace, and the furnace suddenly stops because power is not available, can you imagine the amount of energy required to bring this furnace back to operation? It requires a lot of energy to bring something back from the cold to the point at which you need it to operate. So all of these have an energy penalty. So reliable electricity is important. Energy efficiency in small scale industries is important. And this is the challenge. Many of them use antiquated technologies and old technologies. They don't have the resources to purchase a new technology. They need to be supported through innovative financing and so on and so forth. But I wanted to leave you all with the thought that this is a sector which requires support. We do have a few MSME sectors that are efficient globally, introduce the best practices and so on. But by and large, they are inefficient because they are small scale. They don't have economy of scale. They don't have trained manpower. You need to demonstrate to them rather than preach and talk to them, because they like to see the savings and really feel it, not being talked about it in a theoretical sense. They need to know who else has done it, because if somebody else has done it and achieved some gains, then they would like to copy them. So there are a lot of these issues in small and medium scale industry, which is not there in the large industry, which need to be addressed. But the savings potential is large, and that's the point I wanted to make. Anything between 10 to 20% can be easily saved. Now, the savings potential, I think, is important to understand that it doesn't happen due to just one single measure. It can be split into 4 different scenarios. You have what is known as housekeeping measures, first aid measures. These are simple measures, no cost, low cost measures. You can do it at homes, you can do it in buildings, you can do it in industry, small industry, where there is obvious wastage. You have steam leaking out of a pipe, you have water leaking out of a pipe, you have oil dripping in parts of the factory, and so on and so forth. You have heat loss due to poor insulation. So these are low cost, no cost measures. The return on investment is practically zero. The day you implement it, you start saving. And most industries need to do that. The large industries have all done these low cost, no cost measures. It's the MSME sector that needs to do that. It's a question of good habits, do's and don'ts. Then you have measures, and these do's and don'ts can save you a lot of energy. An inefficient MSME can save 15 to 20% energy right there through little or no investment, by scheduling its operations and so on and so forth. Then you come to the large scale industry. I'm sorry, sorry, not large scale. You come to the industries where one needs to invest for efficiency. Now, that requires an investment. Return on investment generally for efficiency is less than 2 years, in many cases less than a year, 6 months. Investment, let us say, in a combustion control system, investment in a waste heat recovery system, investment in high efficiency motors. There's an endless list of interventions one can do, and many of these interventions require a little bit of engineering design, require consultants to help you through the process. But many of you youngsters can look at this as an opportunity to really get into this business, because there's a lot of career opportunities in the area of energy consultancy, energy audit consultancy, and so on. They are low risk measures, tested, tried, and many industries can benefit from. Then you have the third set of interventions, which could save a dramatic amount of energy, 50, 60% is possible, but it requires a completely different technology of manufacture, different manufacture of dyes and chemicals, a different way of heating. For instance, let us say you're heating a product to dry it. Let's say you're heating paper to dry it. You can use hot air generated through an oil-fired furnace, or you could use infrared to heat it, where you use a little bit of electricity but generate heat enough to dry the paper to the standards that you require. This is one among many, many examples where the technology is completely different. So these are the third. And then you have the fourth, which is the circular economy. I'm not going to get into that. And that's where industries congregate together in a way that output of one industry becomes the input to the other, thereby reducing the net energy consumed in that particular industrial subsector. I am now almost coming to the end of my presentation, but I just thought I'd leave you behind with a few thoughts, and I'll do that in the next 5 to 10 minutes. I'd mentioned right in the beginning that we need to look at both sides of the energy equation, but we really need to look at the demand side of the energy equation, which is what my speech until now has been. But there are opportunities even on the supply side of the energy equation to energy efficiency. I think that's very important to understand. It's not as though you move from supply to demand side and focus all your efficiency efforts on the demand side, but there are efficiency opportunities on the supply side, and they need to be addressed. What are they? One is renewables. You must understand that renewables and efficiency do not compete. They're two sides of the same coin. Renewables substitute fossil energy. And anything that substitutes fossil energy, eliminates fossil energy, is energy efficiency in the long term. So renewable projects and energy efficiency go hand to hand. In fact, the cost effectiveness of renewable in many cases is dependent on end use efficiency. You cannot have, for instance, a solar PV system in a village generating power and supplying power to incandescent bulbs, because the incandescent bulb at 60 watts or 40 watts consumes a lot of electricity, but you could do it to an LED lamp, which consumes only a fraction of that. So obviously you need efficiency on the demand side and you need renewables on the supply side. Also, the challenge that Hari mentioned, that many of you in the younger generation would be moving into a world of no fossil fuel, at least the children will be, is part of a broader strategy known as deep decarbonization, where we reduce the carbon used on supply and we reduce tremendously the carbon used on demand. And the way to do deep decarbonization, one of the pillars is efficiency and renewables. Then you need large-scale storage. That's very obvious because renewables is inconsistent, it is intermittent. Demand and supply continues changing over the day, and you cannot meet demand if supply is through an intermittent source. You need a storage in between, and that's what large-scale storage is about. And then there's rooftop solar, and then you have ultra supergrid. If you recall, I mentioned about improving efficiency of power plants. I said the maximum you can have is 42.5% because of the Rankine cycle limitations, Carnot cycle efficiency limitations because of the second law of thermodynamics. But you have ultra supercritical, which can actually edge these efficiencies to 50–60% by changing the thermodynamic parameters of conversion of heat into work. It's a big subject. I don't want to get into it, but just wanted you to know that ultra supercritical is an area which we in India too are now engaging ourselves. Some of our recent NTPC thermal power stations are supercritical thermal power stations and which are operating at much higher efficiencies than the subcritical station. The use of natural gas is going to make an amazing impact on decarbonization and efficiency on the supply side. Natural gas has a carbon by hydrogen ratio, which is very favorable. In other words, they have less carbon, more hydrogen, and they can be used for all the purposes that oil or coal is being used for. But the question is, do we have enough natural gas indigenously? We don't. We have to import that. Then you have advanced power cycles. You have generation 3 photovoltaics. Now, a photovoltaic, the maximum efficiency you can get out of a solar PV photovoltaic is about 29 or 20, 30%. But you have generation 3 photovoltaics, you can up it a little further, but 10 to 15%. These are silicon nitride cells and so on. A lot of developments in this area. And then similarly nuclear. Then you have high altitude power, which is generating power from power mills which are located at high altitudes where wind speeds are much higher. So this just to give you an inkling as to how one can produce clean energy and the direction in which the world is moving towards deep decarbonization. But the subject which we have been discussing thus far is energy efficiency at the end use side. And these are areas which I'm sure you'll have read about. Electric vehicles is going to play a larger and larger role in this country. For transportation, we have advanced green communities, which is a conglomeration of green buildings, of buildings which use energy and water and other natural resources very efficiently and economically, where the interdependence of energy use in these entities. We have industrial processes, I touched upon it. Many industrial processes, whether it's steel plants, pulp and paper, etc., have undergone rapid transformation in the way in which they use energy and natural resources. For instance, you have you have aluminum cells, which are much more efficient than what they used to be before to manufacture aluminum. You have cement, as I said, which utilize dry process rather than the wet process. They're very inefficient. You have in pulp and paper industry, you have continuous digesters as against large single digesters, which are much more energy efficient. Similarly, in steel plant, we have continuous casting of steel. You have high efficiency pins in ceramic industry, and so on and so forth. So there is amazing amount of developments that are taking place. Then you have hydrogen and biofuels. I touched upon hydrogen in the earlier slide, but I just wanted to leave behind the thought that when you look at decarbonization in India, while supply side decarbonization is important, decarbonization on the demand side is more important because we generate more carbon on our demand side than on the supply side. So what that really means is that we have to now start looking at alternatives to coal and oil at the industry level, at the transport level, and at the residential level. Electric vehicles is an example where we are looking at electricity in place of petrol. But we can also think of hydrogen, which is the ultimate fuel because it doesn't have any pollution, no greenhouse gas effect. And in fact, if products of combustion of hydrogen is water vapor, but you generate that hydrogen through renewable energy and use that hydrogen to make biofuels, and those biofuels are used to replace petrol and gasoline and diesel and so on. That's an interesting cycle. We are nowhere quite there yet. The hydrogen economy will happen by 2040 or 2050, but the elements and the pieces are coming together. And then there's this heat pumps. This is a technology already available. One can upgrade low temperature heat to a higher temperature heat by heat pump at an efficiency which is much higher than using a furnace to heat up air and take the air for whatever purpose you want. So you can use heat of the ground to generate heat to heat up buildings and so on and so forth. And you can use it in reverse and use the heat pump for cooling. So heat pumps are a technology which is now mature and which needs to be used more and more. Then you have rail electrification. Today there are several studies which show that electrification consumes the least amount of energy per passenger mile compared to diesel, and certainly compared to our steam locomotives of the past. So rail electrification is an important element. Then you have teleheating, and I touched upon this very, very briefly when I talked about combined heat and power systems. These are, in a sense, is being used in Indian industry, sugar industry does cogeneration, pulp and paper does, where they use a single source of energy to generate heat and power and meet the power requirements domestically. Excess power they sell to the grid. Heat requirements they use for the process requirements. But if you look at teleheating for, let us say, area, area in a city. Let us say Connaught Place in Delhi is a good example, where one could use teleheating or telecooling to meet the air conditioning loads at the highest efficiency by generating power in a single facility using the exhaust of the power in an absorption refrigeration system to generate cold and then distributing the cold. So these are kind of some systems which are now gaining impact. Then you have indoor agriculture in the entire area of hydroponics, entire area of drip irrigation, and all that comes out of it. Getting the maximum food for every drop of water, I think is getting to be more important. And then you have digital manufacturing, which is again a question of digitalization and using advanced manufacturing, automation, which again is slowly but surely gaining some importance. They're still yet to have commercial parlance, but this is the direction in which energy efficiency is moving. My last slide in conclusion, just to leave behind the last thoughts from my presentation. And if you were to look at these and if these resonate with you and you understand what I'm trying to say, then I will be quite happy because I think the purpose and the objective of my presentation has been achieved. The first is energy efficiency is a resource like oil, coal, gas, and nuclear. I've mentioned it in the past. I need to continue mentioning it, that energy efficiency is not an embellishment, it's not an icing on the cake. It is a resource, an invisible resource, but it's a resource and must be seen on par with coal and oil, spoken in the same breath as the others are. If you do that and if you do it logically, then we will say that we have moved to the demand side of integration. It is clearly India's first few. Several studies have shown energy efficiency has generated more amount of power, which is known as megawatts rather than megawatts, or save more amount of power than renewable energy or for that matter, other sources of energy. The third point clearly jumps out of the first two, the focus on supply to demand side. Energy efficiency is central to all the sustainability strategies. If you recall, I talked about 6 green technology shifts. I call them tectonic shifts. Tectonic because they're awesome, they're national, they're large, and for it to happen, one would need these 6 shifts, and energy efficiency is central to each one of these shifts. And lastly, I hope I was able to make the point that there are significant energy efficiency opportunities in building and industry. So thank you very much and look forward to your questions.
Thank you, Madhu. That was very engaging. I can tell you that we had nearly 300 participants on the call today, and what you mentioned was very, very relevant for how the things are going to be in future. So I'll now open the open for questions, and my request, as I said earlier, put your questions in the Q&A box. Don't put it on the chat box, put it in the Q&A box, and I'll pick them up. I'm requesting both Padu and Dr. Hariharan to be available for responding to the questions, and I'll direct the questions to you as they are coming. So
Sure.
the first one, Padu, is for you, where Gayatri is asked a question: what are the demand side management strategies in India, and what is its impact?
There are classically there are 4 or 5 demand side management strategies. One is peak clipping, because we have peak loads on our systems, which is lighting or air conditioning, as the case may be, and one kind of looks at ways and means to reduce the peak by eliminating those loads or intervening with energy efficiency. Another demand side management strategy, which makes sense, in the Indian context is load shifting. That is moving the peak from evening hours to another time of the day when power is available, so that industry or homes need not get power cuts during the peak hours. Load shifting is something practiced through direct intervention by the state utilities by making it mandatory for certain industries to operate at certain times of the day and so on and so forth, or days of the week. And another way to do it is through pricing. You have tariffs which are cheaper for industry, for instance, to use during off-peak time. So they're motivated to transfer their production to off-peak time. And then you have these measures, peak shifting, and then combination of both of peak load management as well as load shifting. So that's basically what they are. The progress that we have made is been halting, I must say. Some of the private utilities, distribution companies have done rather good work. Many others are yet to do it. And one of the reasons is that we don't have sufficient load research information. It's far better than what it used to be when I began my career in power sector, but it's not as good as what is required to kind of take the decisions to design the dark state program. And these are requirements of understanding precisely how consumers use energy.
Thank you, Padu. I think we'll move on to the next question, which is Dr. Hariharan, and Mr. Murali is asking that, despite so much struggle to conserve energy and water, still some states in India don't charge for water supply, like Tamil Nadu, Himachal Pradesh, etc. Shouldn't this be corrected at the national level?
Well, Delhi is also another example of power being hugely subsidized. We all know that rationalizing our power tariff, well, who is not talking about the water tariffs and what we need to be doing about it? So if this has to happen, it falls in a domain which is beyond experts, Murli, and to all you students. This falls in the realm of the government and of good governance. You heard Rahul Bajaj say yesterday, was it, that this isn't about relief and support that we need post-COVID. We need good governance. So sometimes there are political imperatives and expediencies that make such decisions. We have to live with it in a democracy. I can't really answer that question in terms of how and why states can do this. Let's keep this to our discussions on the expertise and the solutions that are available. I'll leave it there for now.
Thank you, Doctor. Moving on, there's a question from Mr. Jayan Sinha. This is to Padu. A majority of energy efficient technologies implemented in India are sourced through imports. In a post-COVID scenario, what are your recommendations for the policy and industry stakeholders to reverse this trend, enabling wider access to cost-effective energy efficient technologies indigenously across industries, especially MSME?
Well, I'll answer this question in two parts.
By the way, your mic isn't...
we lost you.
Yeah. I think it's to do with where you have stationed your mic. Well, maybe I can, yeah, hello.
Go ahead, Dr. Hariharan, you can take this one, yeah.
Or maybe we'll wait for him while you field another question.
It's important. No, but can you hear me now?
Hello? Yes, we can.
We can hear you.
Yeah,
we can hear you. Padu, we can hear you.
Hello?
Padu.
Yeah,
go ahead, please. Yeah, yes, Padu, we can hear you. Go ahead.
Okay, I think I'll move on, and
please.
Once he comes back, then we'll take this again.
Please, yes.
There is a question from Viresh Sahukar. He's been there previously also. Do you feel going forward the formation of microgrids with power storage solutions coupled with governments also encouraging such developments as we move towards EVs?
Well, it's again a domain. Yeah, go on, Padu.
But I didn't answer Jayan's question. That's why I was trying to answer that. I think
Sure.
maybe you lost me. Can you hear me now?
Yes, we can. Go ahead, please.
Okay, Jayan's question, and I think I'll answer this and then leave it to Hari to take the next question forward,
Sure.
is that we talked about COVID, and I think that's something important to put on the table, that India, the energy losses in India, if it's translated into rupees, is significant, especially in the power sector. And the extent of losses is double of what we spend on health and half of what we spend on education. So can you imagine if we were to reduce the losses, and if those losses were made available to the health sector for the reasons of public health protection, then there's a lot that can be done. So there is a broader element to whatever I'm talking about, and that is the fiscal deficit, which I think is extremely important. That the fiscal deficit of this country, to some extent, depends on the subsidy that is provided to the energy sector, and energy savings can reduce the fiscal deficit. So that's the first part of it. The second part of the question is, I entirely agree with Jayan that we need to develop indigenous technology for energy efficiency. And energy efficiency, unlike energy supply technology, has to be locally homegrown. You cannot transfer an energy efficiency technology because that has more related to the indigenous use of energy, the patterns of energy use, the kind of quality of our energy, and so on and so forth. So I entirely agree with Jayan on that. That's it.
Thank you. So, but maybe you can take. Sorry,
yeah,
go ahead.
Padu, can you take on that next question on the microgrid, if you've heard it, unless you want Ashish to repeat that question?
Can Ashish kindly repeat that?
Okay, so there's a question from Mr. Viresh Sahukar. Do you feel going forward with the formation of microgrids with power storage solutions coupled with government is an encouraging development as we move towards EVs?
I think it's an encouraging development. I think it's an encouraging development for several reasons. One reason clearly is that a microgrid has no transmission and distribution losses. To that extent, one has a lot of energy efficiency embodied in a microgrid. So that is a very major part of it. The second point is reliability of supply. The consumer could also be a producer. So you could have the concept of prosumers, which I think is extremely important. However, there are issues related to microgrids in terms of regulation, in terms of the taking away the market from the large players, centralized grid, and one needs to come out with regulations to protect the interests of the microgrid players, as well as protect the interest of the large centralized grid. But my simple answer to it is yes, it's an important component of energy planning in the country. It can bring in clean energy, energy efficiency in the same breath, and it needs to be pursued with all vigor.
Let me quickly step in here for all of your students. You heard Padu Padmanabhan mentioning prosumer just now. That was a word that first appeared in a book in 1970 written by a person called Alvin Toffler. Those of you who are working on a thesis on, say, near zero design or on near zero water or on near zero energy, please look up prosumer, understand what that means. Understand how, when he's talking of energy efficiency, you need to coalesce such strategies in order to get to your next steps forward over the next 5-6 years of you are taking on a career. Over to you, Ashish.
Okay, we have next question from Muhammad Salam Ali, who's asking how can we save energy in building construction material level, because commonly used materials like cement, glass, and steel need more process before use, which consume more energy.
Salam, I will only say this much to you. Let me take this. There was a pyramid that Ashish Rakeja showed in the first presentation, which is available on the website of the Prem Jain Memorial Trust. Please go back there and try to understand what he meant by that that cascade, by that pyramid of passive elements and then active elements and so on. Today, again, our Padu has spoken about it at some great length on passive as well as active elements that can go into a building. Let's not respond to this now. So please go back to the recordings as well of Padu as well as of Ashish. Over to you, Ashish.
Next question is from architect Ashok Mendonka, who's principal of Beads, Mangalore. Waste plastic has been a global challenge, primarily due to its polluting potential. It's been reported that oil could be extracted from plastic waste apart from other recycle options.
Absolutely.
While we are lying on the mountains of this particular waste, what is stopping us from using this?
Professor Ashok, welcome to this from Mangalore. I know you are from the BEADS, the Bureau Institute of Architecture of Energy and Design. I'm sure your students have also joined in. Thank you for being here today with us. Let me put it this way. Waste is another session that we're going to be doing where we will talk about organic waste. We will talk about plastic waste, of course, and pyrolysis. In fact, in Tamil Nadu, we have at least 4 such installations of about 100 kilo of plastic waste conversion to biofuel. Let's discuss it in that session when it comes up over the next 3 weeks. I shall leave it there for now. Yeah.
The only point I like to supplement here in connection with the plastics is that today cement industry has actually been using waste plastics in their kilns. At the high temperatures at which these kilns are operated, the plastic is reduced to its elements, and it's an important ingredient to clinker. So there's some development on that score.
Sure. Point taken. Yeah.
Okay. So next question is from architect Shailesh Chitlangi. And this is to you, Padu. Can you please elaborate on the focus from supply to demand side management? Because generally we always produce as per requirement, that is from demand to supply side.
That's a very good question. And what is the focus and how do you change the focus? See, if we look at power system planning, there are 3 elements to the power system planning, or rather 4 elements. One is the generation planning. The second is the transmission planning. The third is the distribution planning. And fourth is the end use planning. And all these 4 are done sequentially in the sense that you put up a generating plant and then you plan for its transmission of power, then you plan for the transmitted power to be then taken to cities and towns and villages through distribution networks. And then finally the distributed energy, electricity is then provided to consumers, industry, etc. In a strategy where you look at supply and demand both in a symmetrical way. Earlier, what I mentioned was what I call as sequential planning. You now move towards symmetrical planning. And basically what that tells you is, do I put up a power plant of 1000 megawatts, 100 megawatts, or can I reduce power consumption of 100 megawatts on the consumer side of the meter? And then weigh the alternative. I may be able to save 20, 30 megawatts through efficient end use. I could save efficient distribution and by efficient transmission. I may need not have the 100 megawatt of supply. So that's how you do it. You move towards from sequential planning to symmetrical planning. That's what it is.
Let me pitch in with 2 observations, Ashish. One is there is a participant called Vivek who says that one half of these challenges, may be solved if designers and architects at the first go of it all plan such things in a way that many of these elements don't become bad legacy for service professionals who come in after. Ashish, do you want to add anything on that? I'm sure you've encountered many such situations where the architect gave you a bad legacy.
Well, the energy efficiency starts from the fundamentals. If you remember the energy triangle, which we've been referring so far,
right.
The passive elements contribute. Actually, you have seen that passive elements have a potential to bring down the energy consumption by 20 to 30% in a building.
Easily, absolutely.
And that forms in the realm of architects. If you get the building's basic right, applying technology thereafter is a much more cost-effective solution. The challenge starts if the building is not so well designed, and then we are trying to use the technology to fight the nature, and it's never cost-effective. So I'll stop here.
Yeah, I hope all of your students are listening to him, carefully, because there lies a whole lot of the challenges disappearing if only you know how to design it right the first time. And this isn't only for architects. I mean this for engineers too, especially if you are mechanical engineers and so on. Back to
There's a
you.
question from, I'll quickly move on, sir. There are two more questions
Yes,
I'll
please.
take.
Yes.
There's a question from Nivedita from Thane, Mumbai.
Yes.
In the current situation, as been seen, the digital carbon footprint is rapidly increasing. Do you think this will stay in future, or is it a short-term trend?
Nivedita, I think you know the answer as well as we do. This is going to take some time. It's not going to be easy. We all have to work at individual levels as well as professionals. As professionals, we have to see that we educate all these businessmen who don't have the solutions. You know what Padu talked about when he talked about all these, MSMEs now. Many of them, I can tell you from my own personal experience, simply don't have the knowledge of what they need to do to make their units more energy efficient. I will also answer one of the questions that you have raised, Nivedita, about certification and such. I'm sure it was the same Nivedita Sharma who was asking this question too. Ashish, do you want to say something about the certification
of participation? You covered it well.
Okay.
Covered it well.
So the certification is available for all of you. Please go back to the website. Please speak to Sakshi also about this. Back to you, Ashish.
Just the last question of the day from Dhanlakshmi. Why are there not many sustainable materials being experimented in Indian buildings in view of energy efficiency?
It's purely to do with demand. If you have enough demand for all these products, there will be enough manufacturers, enough technologies who will move in. It's the same story in water as well as in energy. There are lots of things, and it's all to do again with that question that Murli Anur asked. How do we, if you were to pay 20 rupees to a liter of water, if you were to pay 25 rupees to a unit of power, you will look for technology, you will look for solutions. And that has not changed, and that is not in the realm of expert consulting.
Thank you. Thank you, Doctor, and thank you, Padu.
A couple of, go on, Padu, before I offer a few things to the students.
My last point, and this is to do with buildings and architects. One of the things that building owners want is reliability of supply. So to a large extent, the costs of putting up a captive power plant, like a diesel generating set, etc., is an important element to the total cost. Now, efficiency can actually obviate the need of this captive power. So somebody asked this question on demand and supply, and I talked about it in a more general sense, even down to the level of a building where there is standby power. One can eliminate the use of standby power by having more efficient end-use equipment and technology. I think that's very, very important for architects to understand that they can a very positive contribution to efficiency.
There's one more to add to that, Ashish, if you don't mind.
Doctor, we'll like to bring this to an end, and I'd like you to, before I give my thanks to everyone, we also know about a little bit about what subject are we talking on the next Thursday.
The next one is on freshwater. The theme is, should freshwater be used just once? We have pursued a certain kind of technology for the last 100+ years. So what's the way forward into the next 2 decades? There will be more details posted by the weekend.
Thank you, Doctor. Thank you so much. And friends, thank you for being here. We had nearly 300 participants today. Wonderful session from Padu. Thank you, Padu, for taking time out and being part of this Living Building series of PJMT. Your association with Dr. Jain is well known, and thank you for the rich tribute to him. Dr. Hariharan, thank you for the constant guidance that we get from you. You are the energy source for the entire PJMT, and thank you for taking those questions, because everyone has benefited from the huge knowledge that you carry. So friends, just the last word. For the Living Building series, any questions you have related to green, as I said earlier, write to Greeno, which is the green mascot of PJMT. Go to the PJMT website. The website is appearing on your screen. Go there, put your questions, and from that point onwards, one of the experts will address your question. You'll get the answers. So our series continues. We are now at the end of 50% of our series of 6 in this, and the next week, next Thursday at 10:30 a.m. we'll have the the fourth master speaker will come in talking about the water, which is very, very important. We saw a lot of questions emerging in all the last the three talks that we have had. So we'll cover the water as next. So look forward to having you all here. Please do register, pre-register, because the seats are limited. Do spread this amongst your friends, amongst your peers, the wonderful work that is happening here, what you can listen to the master speaker, and send us your suggestions. Thank you very much, and have a great week ahead. Thank you, and stay safe.
Thank you all of you.